Welcome to the fourth podcast. In this podcast, we will explain how to find the optimal quantities the consumer will consume. From the optimal consumer choice, we will derive the demand curve, which gives you the consumed quantity of a good for each price of that good. We will also define what the consumer surplus is. So Jenny is a consumer and her objective is to maximize her utility. The problem is to find the optimal quantities that maximize her utility while respecting her budget constraint. So you can write this as maximize the utility which depends on x1 and x2 subject to the budget constraints. Note here that we use the equality between income and expenditures. And why is that? Because if you don't use your whole income, that means you still have income to increase your utility. So your satisfaction is not maximized. Thus, you need to exhaust your budget in order to get the maximum utility level. So we have to solve a problem of optimization with the constraints, which can be solved with the Lagrangian method. The Lagrangian is equal to the utility function plus lambda times I, the income, minus P1x1 minus P2x2. What is the interpretation of the Lagrange parameter lambda? Lambda indicates by how much the utility of Jenny rises when we give her one more corona, so when we relax the budget constraints by 1 unit. If we now differentiate with respect to x1, x2, and lambda, we obtain 3 first-order conditions. The first condition relates to the differentiation relatively to x1, and it can be rearranged. The second condition, relatively to x2, can also be rearranged in order to equalize the two lambdas. The third one is relatively to lambda and equalizes Jenny's income with Jenny's expenditures. So the first two conditions, they can be rearranged to find the following condition, that the ratio of marginal utility has to be equal to the ratio of prices at Jenny's optimum. Let's analyze a bit further this condition. What does the left-hand side stand for? As I explained in the third podcast, this is the marginal rate of substitution. So graphically, we saw that this is the slope of the indifference curve in absolute value. Now, the right-hand side of the equation. This is the price ratio, which is also the slope of the budget line in absolute value, graphically. So the condition required to find the optimal bundle Jenny will consume says that the slope of the indifference curve is equal to the slope of the budget line. So this means that the budget line is tangent to the indifference curve. And the point of tangency gives you the optimal bundle. Let's give an economic interpretation of the optimal consumer choice. Jenny has a budget constraint represented by the budget line. She can afford all the bundles below and on the budget line, but she can't afford any bundle above the budget line. She also has different levels of utility, so different indifference curves. Let's pick one at random. Can it describe an optimal situation for Jenny here? Clearly, it cannot, because Jenny cannot afford the consumption bundles above the budget line. It exceeds Jenny's budgets. What about this indifference curve? Well, not really, because there are consumption bundles which could yield higher utility than this level, so it is not maximizes Jenny's utility. With this curve, Jenny does not exhaust her budget. So the only curve which both maximize the utility level and exhaust Jenny's income is the indifference curve, which is tangent to the budget line. And this is where the conditions the condition holds. The optimal bundle then contains x1 star of good 1 and x2 star of good 2. So x1 star and x2 star are the optimal quantities that Jenny will consume. So we have seen which consumption basket Jenny will optimally choose given her income and good prices. But we also want to know how her choice changes with prices. Equivalently, we want to derive her demand curve. We can do this graphically. In the upper diagram, we are given the optimal bundle given a certain price and a certain income. So at price P1, Jenny is willing to consume the quantity x1 star of good 1. We can position the optimal bundle on the demand diagram given the price P1. Now, what if the price of good 1 increases? Then it makes I over P1 decrease. And we can draw the new budget line, which has a more negative slope than before. Thus, Jenny can afford less than what she could in the previous situation, since her income didn't change, only the price of good 1 increased. What's the optimal choice with this new situation given her new budget constraint? Here is the new maximum attainable indifference curve. So she consumes less of good 1 and more of good 2. So on the demand diagram, we can say that at the new price P1 prime, Jenny consumes x1 prime star. And so on. So we can do this for all prices so that we get the entire demand curve of Jenny, which gives us the maximum price Jenny is willing to pay for each quantity of good 1. Notice that the demand curve is downward sloping. How can we interpret that? At low levels of x1, the consumer is willing to pay a lot to acquire more of good 1. But at higher levels of x1, the consumer is willing to give up less money to acquire a little more of good 1. So we can interpret the demand curve as the maximum price that a consumer is willing to pay for a certain amount of good 1. Note that we can do exactly the same for good 2, so each good is associated to a specific demand curve of the consumer. Now that we have derived the demand curve, let's determine Jenny's consumer surplus. For the sake of simplicity, we assume here that the demand curve is linear. If the market price is P1M, Jenny is willing to consume x1 star. What monetary gain does Jenny have when she purchases x1 star units of good 1 at price P1M? So this is what says the consumer surplus actually. For the first unit, the maximum price that Jenny is willing to pay is P10, but the actual price she must pay is P1M. So the surplus of the purchase of the first units is the difference between P10 and P1M. Now we can add up all the surpluses over all units of good 1, as we did for the first unit, until we reach the optimal quantity x1 star that Jenny is going to consume. And that gives you Jenny's consumer surplus. So the consumer surplus is the area below the demand curve and above the market price. This is the total amount that Jenny is willing to pay for x1 star units of this good, minus the total cost of purchasing this good, which is the rectangle P1M times x1 star. Let's summarize what the consumer surplus is. This is the total amount that the consumer is willing to pay for a good, minus the total cost of purchasing this good, which leaves you with the blue area on the graph, namely the consumer surplus. So graphically, this is represented by the area below the demand curve and above the market price. More generally, the consumer surplus is a measure of the consumer's utility when purchasing a particular good at a certain price. In summary, we have drawn upon the Two-Foot podcast to understand the optimal consumer choice, the demand curve, and the consumer surplus. In the next podcast, we will focus on the other type of agent, which is important in economics, namely producers.